Hi everyone, thanks for coming. My name is Aaron Lee. I am a software engineer at Reconstruct. We are right over there, upstairs. I have to give the obligatory, we're hiring, which is my website. So any engineers, front-end engineers, back-end engineers, come say hi, Reconstruct Inc. We do construction management software. We do it with drones, so it's awesome. But what I'm here to talk about today is Kubernetes. I'm sure everyone has heard this term recently. Kubernetes, they shorten it to Kates because Kubernetes has a lot of vowels in it. It's kind of weird to spell. I'm trying to answer this question, what is Kubernetes? I'm not going to make you a cloud native foundation certified Kubernetes operations engineer or any of that. I'm just going to give you enough information that if you see tweets about Kubernetes, if you see blog posts, you can actually read these and understand what's going on and not be totally confused at the end of it, because there's that gap between, you know, having heard the term and actually understanding what this thing is. So what is it? It's container orchestrations. You have lots of these containers that are running. It runs them for you. It's done. No, that's not actually that's not a helpful definition, but that's pretty much all you're going to get from the website. Because you notice, like Cloud Native Foundation, they have like 400 some projects. This is a massive organization. They run the gamut from monitoring and deployment, and they get it's called a service mesh, the interaction between your applications. But it all kind of started with this thing called Kubernetes, which came from Google. And so I'm going to kind of start this story by talking about its original problem. Like, what is it actually originally trying to do, and why did people start making this thing? As I said, it came from Google, which meant it's going to try and solve problems that are sort of like a Google-ish kind of problem. It can do all kinds of stuff now. It can start, I'm sure you'll read about, you know, running databases and all this, but like my suggestion is first focus on running a kind of a googly thing. So you have to ask, what is this googly sort of service? It's going to be containerized. This needs Docker. So you're going to have to know Docker. That is an entire another talk. That's far beyond the scope of right now. But there's a lot of really great tutorials out there. So I'm just going to start with the assumption that you've gotten your application running in Docker. So one of the really nice things about this is it gives you a build artifact. Like, you don't have to run npm only once on your development machine or on your CI pipeline, and you don't have to worry about running that when you deploy to production. It's all wrapped up into this container, which is, you know, super nice. The container is also stateless, so you shouldn't be like saving things to disk in your Docker container. If you do that, it might go away. Like, you might be running in another container, just restart it at any point in time. So this is really running a web service. Think about it like something that talks to a database on one end, talks to users on the other end, sits in the middle. That's kind of the bread and butter of where Kubernetes started. Yeah, it's a network. So one of the other things, it will take care of doing things like SSL terminate or TLS termination for you if you're running. If it has been configured to do this, if you're running on like Google's Kubernetes or AWS Kubernetes or Azure Kubernetes, they will configure it to set up a load balancer for you and to set up the TLS termination, which is super convenient that you're not having to run Nginx or something in front of it. One of the other things is that you're running a highly available service. So this will do things like watch the amount of CPU or amount of memory you're taking and actually scale up more resources for you. It will start other containers. So you have you might have 6 containers running that are all serving, and you have a huge inrush of traffic. It will spin up more resources for you to manage this, which is, again, very convenient. Spin up more resources, use them when needed. When you're done, you can let them go, and you let someone else, you know, release that. You're not paying for it all the time. Yeah, and it'll manage deployments for you as well. That's a more advanced thing. Talk about that later. One of the big things with, oh, there's 2 of these. Sorry. One of the other big things with Kubernetes is that your applications can be frequently changing. So this is, it manages deployments for you. So you can, you know, you hacky on something, make your pull request, make a commit, let your CI pipeline actually build a new container for you, and Kubernetes will take care of deploying that for you. It'll even do cool things like spin up one new instance, add it to the load balancer, tear down one of the old containers and roll them like that for you. If there's errors, it'll roll back for you. So there's a lot of intelligence built into Kubernetes to do things that would normally be piecemeal, a whole bunch of different services that you'd be running. Now you could do them all with Kubernetes. Yes, the most important thing, you don't control the hardware or the service underneath it. So you write your application, you talk to Kubernetes. You don't have to worry about, is this running on Azure or AWS or our in-house Kubernetes cluster that our SRE team is running. Like it's just you've written your description of how your service works, and you just talk to the Kubernetes. Of course, there's always gotchas in there. There are details, but for the most part, it is a reasonable abstraction layer above a cloud service. It's like, everyone's like, oh, virtual machines, those are abstraction above the hardware itself. And like, the cloud service is an abstraction above the virtual machines themselves. Well, now we have Kubernetes, which is sort of this high level thing that you can talk, as long as your service can be run on Kubernetes, you can then take that sort of easily and kind of plunk it down into different cloud infrastructures. I know I'm selling a lot here. There's a lot of details, but it's far easier than taking a normal 3-tier web app and trying to deploy that to different cloud infrastructure. So traditionally, these kind of services, they were, like I said, a bunch of virtual machines. You had a bunch of Terraform that was possibly would work across multiple different cloud providers. And that would spin up the infrastructure that you needed. It would probably do it correctly. You'd run Ansible, and hopefully your application would be off and running. This was often buggy. I don't know if anybody's worked with a deployment situation like this, but you end up with a lot of these special snowflakes that we've got this deployment, and it's different in this way because Google's decided that they want to change something with the way networking works. So it does often require a lot of help from your operations team. And it also ends up being tightly coupled to each type of infrastructure you want to run on, which would be nice if we didn't have to do that. So Kubernetes, the first thing, you've written your application to run in a container. So now that once you have this container, you just want one file that describes what does my application look like. You don't want to describe what does the cloud service I'm running on. Okay, you want to say, what does my application look like? Well, how many instances do I need? How much memory do I need? Do I need a load balancer? What other applications should I be talking to? Should I have a network connection that allows me to access the Mongo instance? Should I have a network connection that allows me to access Redis? You can actually control these things in Kubernetes. It's just a little line. It'll take care of the Docker network connections for you. So yeah, let Kubernetes sweat all these little details for you. And then the real power of this, really what I hope everyone gets, is that it is this abstraction layer between a cloud service, between dedicated infrastructure and your application itself. So you're writing this file, you're designing how your application runs, not how your infrastructure runs. And the cool thing about that is you can pay someone else to deal with the infrastructure. That's what SREs are for. That's what GKE, like Google's Kubernetes or Azure's Kubernetes, let them deal with it. Let them take care of upgrading the Kubernetes controllers themselves. Let them take care of upgrading the hypervisors. So you just take this whole bunch of infrastructure infrastructure cost you used to have, the cost through human hours of dealing with this stuff, and just let Google deal with it. So it's what we pay them for. So what I want to do now is go through a couple of terms you're going to hear in there. So when I say a service that's running Kubernetes, I just mean your app. That's the program that's running. It's called the service. So there are pods on there. A pod is a running instance of your container. There's some caveats in there. There can be multiple other containers in there, but a pod is, you can think of it as one thing that's running. There will be the manifest is this YAML file that describes everything. I haven't actually gone into the format because YAML makes people's eyes glaze over. Just go to kubernetes.io and there's an example of the YAML file, and they spell out in great detail how all of it is structured. The it's YAML. Sorry. So the deployment is a group of pods. So you think of a deployment as like your production deployment. You would have maybe 15 pods running in there, but you can, when you go to update versions, you would make a new deployment. So you're changing your version, and Kubernetes, like that's what they call a deployment. That's what does your I forgot the term now. Totally blanked. Sorry. Yeah. So deployment, and it will take care of rolling out your application. It will take care of doing canaries for you. So you start one container. You can write a script in there, essentially a line that says, "Run this thing." Usually, it's you help your health endpoint. You pull that. If it doesn't come back as a 200 or returns, some error condition, stop the deployment. Like, don't roll out any more containers, which that has saved me quite a few times. So the namespaces are groups of deployments, groups of resources. This is kind of a high-level way that you can make sure that you're not going to accidentally do something to production when you're making experiment and development. And then, yeah, the pods. kubectl is the command line app. There's a lot of debate about how you pronounce that. The author calls it kubectl, but kubectl. And the other big thing to worry about is secret management. Secrets being anything you wouldn't want exposed out to the world. And you've had database passwords, any sort of JWT, your tokens, any of those things. Don't put those in the manifest file. Like, don't put them in the YAML. Don't check them into source control. Kubernetes has a way where you can put essentially an environment variable where you can, from the command line, using kubectl, set your secrets, and it will inject them into the container for you, either as environment variables for your application or as a file in the Linux file system, etc/whatever, and it will have your secrets in there, and so your secrets never get exposed out through any of these YAML files. So it's a thing to definitely watch out for. One of the big things with the secrets, they are stored in console, I believe, or etcd, but they are base64 encoded and they are not encrypted. You have to do some funkiness to get them encrypted. I know Google does that internally, but it's a thing to look at, like how the secrets are managed, or at least to know to ask that question before you trust something into the Kubernetes. The Ingress is, think of it like a load balancer. You can configure your port that's exposed out to the real world. On the other end, you configure your container so that your container itself doesn't talk to the real world, which is a nice little extra layer of security, but it also does the load balancing for you so that you don't have to worry about using your AWS ELBs or any of those kind of things. And then the service mesh is what makes your containers talk to each other. It does a lot of cool things like it'll do your encryption for you. It'll do, if you get a 500 from request, like you make a request to or through the service mesh to another service. If that gets back a 500, the service mesh will take care of retrying that and not actually giving you the response until you do get the correct error. So like the service mesh, there's a lot of them out there. They're a thing you should definitely Google. What next? For everyone who wants to actually try this, if you have a Linux machine, any kind of Ubuntu machine, there's this project by Canonical called microkates, and all you do is it's a snap that's there. So you say like sudo snap install microkates, and you have a Kubernetes cluster running on your laptop. And you can, it's great for development. They have a really fantastic tutorial. I could go and copy bits of the tutorial out, but I mean, it's helpful just to be able to touch things on your own. So I highly recommend checking out their tutorial. And I also hope that now people at least can sort of answer the question, what is Kubernetes? So I'm Aaron Lee. That's my email address. I do have a couple of questions. So is there anyone here who has both used Kubernetes and is willing to talk to other people about it? Curious? Anyone? Okay. So that means that come ask me questions afterwards. I'll try and answer as best I can. Also, the other thing I've got to advertise, I run a meetup on Thursdays usually. Coffee shop coders. We go to coffee shops and we talk about code and write code. So come say hi. It's a lot of fun. All right, thank you.